Okay, so this is 8.2 law of cosines for Precal. Law of cosines, if you've got a triangle, this is angle A, this is angle B, this is angle C, letter A, letter C, letter B. Law of cosine says that if you want a side length, like side A would be B squared plus C squared minus 2BC cosine A. So it's more of a pattern than a formula. So if you want B, it's the square root of A squared plus C squared minus 2AC cosine B. And then if you wanted C, it would be B squared plus A squared minus 2AB cosine C. So it's always the side length and opposite angle on there, on all of them. Then if you want to find an angle measure, because you're going to have to find an angle measure, which the computer won't show you to you this way, so you're going to have to make sure you write this down. If you want angle A, it's going to be the inverse cosine of B squared plus C squared minus A squared all over 2BC. And then, now my light's kind of glaring there. That's the inverse cosine. And then if you want angle B, it's going to be the inverse cosine of A squared plus C squared minus B squared all over 2AC. Again, the computer won't show you this. I'm giving you a shortcut formula to use for the angle measure, so you need to make sure that you use this shortcut. This would be inverse cosine of A squared plus B squared minus C squared all over 2AB. So that's how you find the angle measures. Okay, so then on 8.2, sometimes you're going to start with law of cosine, sometimes you're going to start with law of sines. So on one triangle, if you have two sides and the angle between it, like on this one, you're going to have to start with law of cosines. You don't have a choice. You have to start with law of cosines because you don't have enough to set up law of sines. Law of sines, you have to have side over angle to be able to set up law of sines. So this is going to start with law of cosines, and you just have to solve the triangle. I'll tell you to solve it. So A is going to be the square root, and there's not really a formula to write. You just set up the pattern. 11 squared plus 27 squared minus 2 times 11 times 27 cosine of 28, because the angle opposite is that. And then you just type it in your calculator and round to whatever the computer asks you to round it to. So second cosine, I'll have to type that in. It's going to be about 18 for that. For little a, it's going to be about 18 if you round it to the nearest whole number. Then you've got to find angle B and angle C. So angle B, you're going to want to use law of cosines. So law of cosines would give you inverse cosine of A squared, which we just found is 18. 18 squared. Yeah, that's going to be the best thing to do. Minus 27 squared, sorry, plus 27 squared, minus 11 squared, because you're looking for B, and it's opposite 11. So that's why you put 11, that's why you're subtracting 11, and then 2 times 18 times 27. Then you type that in, do inverse cosine, and make sure on this, when you put in this inverse cosine, you're going to do second cosine. You're going to open up a second set of parentheses, and you're going to put in 18 squared plus 27 squared minus 11 squared, and then divided by parentheses 2 times 18 times 27. And that gives you 16 if you round to the nearest whole number. So angle B would be 16. And then to find the other angle, you can just subtract. To find angle C, you just do 180 minus 28 minus 16. So 180 minus 28 minus 16 would give you 136. So angle C is 136. And then everything is solved. We got little a, we got angle B, and then we subtracted to get angle C. So that's one type that you're going to see where you have to use law of cosines. Then the other type you're going to see is where you're just given side lengths. So like sometimes you'll be given a triangle, sometimes you won't. This is 12, this is 20, this is 11. So if you're just given side lengths like that, then you've got to find angle measures. So you have to use the inverse cosine. So if we want to find, this is angle A, this is angle B, this is angle C. So we'll find angle A first. 11 is opposite A, so we start with 12 squared plus 20 squared minus 11 squared over 2 times 12 times 20. So this is what it looks like. 20 squared. 12 squared plus 20 squared minus 11 squared. Again, we're looking for angle A. So that's why we subtract side A. That's why we subtract the 11. And then put everything else in. And then type that on the calculator. Again, let me show you again how you do that. Second cosine, parentheses, 12 squared plus 20 squared minus 11 squared, close parentheses, divided by 2 times 12 times 20, which would give you about 28. So angle A is about 28. Now, depending on what they want you to round it to, here if we rounded it to the nearest hundredth, and you're going to have to round it to whatever you asked to round to. So A is 28.21, that's A. Then you've got to set up a law of cosines for B, and I would go in order. I would go in alphabetical order because it'll throw you off if you don't, and that's what the computer's assuming that you do. So if we want angle B, that means we've got to subtract the 20. So we do 12 squared plus 11 squared minus 20 squared, because 20 is opposite B, divided by 2 times 12 times 11. So that's what it sets up. This is angle B. That's what it sets up as. And again, let me show you again how to put it on your calculator. Second cosine, parentheses, 12 squared plus 11 squared minus 20 squared, close parentheses, divided by parentheses 2 times 12 times 11. Gives you about 120.75 if we're rounding to the nearest hundredth, which we should because we had to round to the nearest hundredth on A. So that's B 120.75. Then to find oh crud, guys, I set my triangle up wrong. Hold on. This is C, this is B. That's C. And then we've got B left over. So this should be C that we just found. I put my C and my B in the wrong place. But so C is 120.75. C should be across from the 20. I just looked at the triangle wrong. So make sure that you get your angles in the right place. And then we do 180 minus 28.21 minus 120.75. So 180 minus 28.21 minus 120.75, we get 31.04. And so it's solved because we had the side measures, now we have all the angle measures. And you'll see another one like that where you've got all the side lengths. Sometimes they won't give you the triangle. It doesn't matter. So A is 1, B is 5, and C is 8. So these are all side lengths because you don't have degree measures and they're little letters. So we just set up to find one angle. So we could find angle A would be inverse cosine of 5 squared plus 8 squared minus 1 squared all over 2 times 5 times 8. Notice these two numbers always match. And you're always subtracting the side opposite the angle you're finding. Side A, angle A, we're subtracting that. Okay, this is the shortcut. This is not what the computer shows. This is the shortcut. So we type it in. Second cosine, open another set of parentheses, 5 squared plus 8 squared minus 1 squared, close parentheses, divided by 2 times 5 times 8, close parentheses. Again, gives me an error, so I want to try it again, because sometimes it won't work, but I always try it twice. 5 squared plus 8 squared minus 1 squared, close parentheses, divided by 2 times 5 times 8. And we get it again. So that means there's no triangle. And again, there's no ambiguous case on this. So you may get one or two that there's no triangles. Otherwise, they should work out. Okay. Again, if you've got all three sides, use law of cosines. Sometimes you'll have to use law of sines. If you have something like little a is 59.97, little b is 39.23, and big C is 54.6, this means you use law of cosines because you don't have any matches. You don't have side C, and you don't have angle A, and you don't have angle B. So it's like you've got two sides in the angle between. So this, you've got to start out with law of cosines. So you'd have to find side C, which would be the square root of 59.97 squared plus 39.23 squared minus 2 times 59.97 times 39.23 cosine 54.6. And I read out of room. Then you type that all on your calculator to get side C. It comes out to be about 49.09 on that. And then you have to find, you have to solve the triangle. So we found side C. Now we need to find angle A. So if I want to find angle A, that's inverse cosine of 39.23 squared plus 49.09 squared minus 59.97 squared, because I'm looking for angle A. So side A is what has to be subtracted. And then 2 times 39.23 times 49.09. And then you type that in your calculator. Again, I want to show you again just to make sure that you don't forget. So second cosine, parentheses, 39.23 squared plus 49.09 squared minus 59.97 squared, close parentheses, divided by parentheses, 2 times 39.23 times 49.09. So you get about, says to round to the nearest tenth, so you get about 84.8 for angle A. And then to find the other angle, 180 minus 84.8 minus 54.6, because we were given C. So this is finding angle B. So 180 minus 84.8 minus 54.6. And we get 40.6. Okay, so that's what happens when you're given two sides and an angle that doesn't match either of the sides. So you have to start with law of cosines. So you'll see that. Then you're going to have to choose, like, the first thing you're going to be asked. Well, you're going to be given, like, A is 68 degrees, B is 13 degrees, and B is 23.7. Then you're going to be asked, the first thing you're going to be asked is, which law do you use? Well, notice you've got a match. You've got an angle and a side. So that means you can start with law of sines. And really, you can start with finding angle C very easily, 180 minus 68 minus 13, which gives you angle C is 99. Then you set up law of sines. So we'd put A over sine 68 and B 23.7 over sine 13. So then again, one move needs to be made. So 23.7 sine 68 over sine 13. Type that in your calculator. You get about 97.7, about that, depending on what you have to round it to. And then to find side C, because we've got B already, so to find side C, Well, C is over angle C, which is sine 99, because we found angle C right here. It's 99. So C over sine 99, and use the 23.7 over sine 13 again. So then one move, 23.7 sine 99 over sine 13. That gives you about 104.1 for side C. But again, one of the things you're asked for is to choose that you start with law of sines and then go through the motion. Sometimes you have to start with law of sines, sometimes you have to start with law of cosines. Again, if you've got side lengths, you're looking for angle measures, and you use law of cosines, which I've shown you a couple of those. If you are just given angle measures, it can't be solved. So that's the first thing that you'll pick, and then you have to go through, and for all the sides, like side A, you're going to put no solution because they have you choose them. Like you have to go through and you have to answer for side A and put no solution, and answer for side B and put no solution, and answer for side C and put no solution. So make sure you fill out all of those slots. It can't be solved. If you're given all three angles, it can't be solved. You can't do it, so you just go on. Again, if you're given all three sides, use law of cosines. I've set up those angle measures for you enough for you to be able to see that. And then you're going to have some word problems. Let's see. So one, we've got feeding and observing sharks has become a popular attraction at water parks. The floor of a newly constructed shark pool is in the shape of a parallelogram. So it's in the shape like this, a parallelogram. It had sides that measure 39 and 50 because it's a parallelogram, so they're congruent. So this is 50 and this is 39. To meet the minimum requirement length for the shortest diagonal, the angles must be 80 degrees and 100 degrees. So 80 degrees and 100 degrees. And let's see, we want the lengths of the diagonals of the pole round to the nearest foot. Okay, so we want this distance, like we want both diagonals. We want both the lengths of diagonals. So this would be X. Say it's X. So it's going to be opposite 80. Using 50 and 39. So I called it X. Square root of 39 squared plus 50 squared minus 2 times 39 times 50 cosine 80. That's finding that one. So we want that to be, it's about 58. That's your shorter one. And then if you want the longer one, so if we want the longer one, we can call it Y, and it's going to be opposite the 100. So the only thing that changes, 39 squared plus 50 squared minus 2 times 39 times 50 cosine 100. So that's the only thing that changes is the angle measure, because your sides are still 50 and 39. And then that is about 69, and that's the longer one. And it has you specify longer one and shorter one, so make sure you put the longer one on the longer one, shorter one on the shorter one. Then you have another one that it has a house drawn. You really don't need it because they have a setup like this. 39.25 and 24.9, and you're wanting AC. So you're wanting this right here. It's set up, it's perfect law of cosines. Like there's no tricks to it. You want that X, so it's the square root of 39.25 squared plus 24.59 squared minus 2 times 39.25 times 24.59 cosine 71. And then type that on your calculator. It's about 38.95, like that. Again, make sure that you are in degrees, that your calculator is in degrees, not radians. Make sure that when you go to your calculator, that when you go to mode, that your degree is highlighted like mine is. Otherwise, this will all mess up and you won't be able to get the right answers. Okay, then again, a skater skates along a straight path from point A to point B. Two streets intersect at point C. They also intersect the path at points A and B. So we've got this. It's a triangle. AC is 0.5. BC is 1.5. The included angle is 112. And we want to know that distance right there. So x is the square root of 0.5 squared plus 1.5 squared minus 2 times 0.5 times 1.5 cosine 112. Again, side opposite angle, side opposite angle. And then that's about 1.7 miles. You have to round to the nearest tenth. So again, just read the instructions, what you have to round it to. Then you're given a pitcher and the batter. And you've got from the batter, it's up this way. Let's see. A batter in a baseball game drops a bunt down the first baseline. It rolls 20 feet at an angle of 18 degrees. So it rolls 20 feet. So it's a bunt. So it rolls 20 feet at an angle of 18. So this angle right here is 18. That little angle right there is 18. It's a straight up, you know, from the batter to the pitcher, it's straight up there. And then let's see, so we want, how far must the pitcher go? So we want this distance right here. And let's see, the pitcher's mound is 60.5 feet from home plate. We need this angle right here, and that's where you have to be careful. When you are looking at a diamond, at a baseball diamond, it's really a square, and every angle is 90 degrees. So this whole angle right here is a 90-degree angle. Well, we've cut it in half, so that means this is 45. So we do 45 minus 18 to get that angle right in there, which is 27. So this angle right in here is 27 degrees. And we want x. So again, perfect law of cosines. X is 20 squared plus 60.5 squared minus 2 times 20 times 60.5 cosine 27. And that's going to be about 43.6 feet, rounding to the nearest tenth or whatever you're asked to round it to. And then you got another drawing. This is 40, this is 55, and this across here is 85. That's the drawing that we're given. It says a weight is supported by cables attached to both ends of a horizontal beam as shown in the figure. What are the angles formed between the beam and the cables? So we want these two angles. The angle between the beam and the 40-foot cable. So this is the first one we're asked to find, is that beam there. So this is where you do the inverse cosine of 85 squared plus 40 squared minus 55 squared over 2 times 85 times 40. That's the way you find the angle measure. We're finding this is angle A. This is between the beam, which is 85. This is the beam, and the 40-foot cable. So that's the first one that we're finding. Again, I want to show you again how to put it in your calculator. Second cosine. Open another set of parentheses. 85 squared plus 40 squared minus 55 squared. Close parentheses divided by open parentheses. 2 times 85 times 40. Close parentheses. And you get about 31.5, depending on what you're asked to round it to. And then if we want to find angle B, it'd be inverse cosine of 85 squared plus 55 squared minus 40 squared, because 40 is opposite angle B that we're looking for, over 2 times 85 times 55. And again, type that in your, I've shown you how to type that in your calculator. That's about 22.3, 22, depending on what you're asked to round it to. Then you've got a sail that is in the shape of an isosceles triangle. Isosceles meaning two sides are congruent. Has a vertex angle of 57. It's the angle included between the two sides, each measuring 20. We want to find the length of the other side of the sail, so we want this one. Again, it's an isosceles. That's why both sides are 20. So x is square root of 20 squared plus 20 squared minus 2 times 20 times 20, cosine 57. That's about 19.08 or 19.1, depending on what you're asking to round it to, and it's in feet. So there's that one. One last one. A triangular swimming pool measures 50 feet on one side and 34.6 feet on the other side. So triangular swimming pool, 50, 34.6. These form an angle. If these two form the angle, that means that's the angle between. So it sets up like this. And we want, how long is the other side? So perfect, easy law of cosines. 50 squared plus 34.6 squared minus 2 times 50 times 34.6, cosine 57.4. And that's about 42.81 or 42.8, depending on what you're asked to round it to. And there you go. Okay, so that is law of cosines. That is due Tuesday, 3/31. By, I think yours is by 11 a.m. I will open that up tomorrow. I think it'll open, because this is Thursday night, so I'll open it up Friday about 10:25. So you have all weekend until Tuesday to get it done. Make sure that you copy the notes and send me copies of the notes with the assignment. And that's it. I'll send you a link for this video.